Today we're going to be talking about the inverse trigonometric functions. And we've already kind of dealt with these on our calculator, but many of these questions are going to be without your calculator. So we already know when you're looking for the sine of pi over 6, that means the sine of angle pi over 6 is 1/2. So what if we want to know at what angle does this sine equal 1/2? So that's going to be the inverse sine, and that's what that notation looks like. Okay, at what angle, okay, is our sine equal to 1/2? Because of how our inverse trig functions look, and I want you guys to write down the left half. You don't have to worry about writing down the graph, but I want you guys to write down this left half of the chart. Okay, so inverse trig functions. Okay, arc sine, arc cosine, arc tangent. There's two different ways we could write it, and I'm seeing this arc sine, arc cosine, arc tangent out a lot more often. I didn't see that for a few years, but now I see that a lot. Or sine to the -1, cosine to the -1, tangent to the -1. Okay? This means at what angle is our trig function, whatever the ratio x is. So the domain is the ratio. Okay? The ratio from our unit circle. Okay? The range is an angle. The angle that we're talking about. Okay? So notice how here, for sine, it's from -pi/2 to pi/2. -pi/2 does not mean the same thing as 3pi/2. Okay? It's from -pi/2 to pi/2. Our cosine is from 0 to pi, and from pi/2, -pi/2 to pi/2 for our arctangent. So what that means, okay, inverse sine is restricted to quadrants 1 and 4, where this is -pi/2 to pi/2. Inverse cosine is restricted from 0 to pi. Inverse tangent is from -pi/2 to pi/2. So I want to emphasize that all these angles in this fourth quadrant are going to be negative that we're looking at. All of these angles are the negative versions of the angles. It's not going to be 330 degrees. It's going to be -pi/6 or -30 degrees. Okay, another key thing that I want to make sure you guys have. The expression sine to the -1 is read as the inverse sine. Okay, it does not mean the reciprocal. Okay, it does not mean the reciprocal. It means the inverse. Kind of like before when we said that f to the -1 of x, that stood for inverse. That's why this means inverse. Okay, and I want you guys to keep this in mind. At what angle does the sine of this ratio, okay, at what angle is the sine this ratio? Okay, evaluating trig functions. Okay, again, think about it like this. At what angle does cosine of that angle equal -√3/2? Okay, now what you have to keep in mind, cosine. When we're looking at cosine, we're just going to be looking on our unit circle, okay, in quadrants 1 and 2. In quadrant 1, all of them are positive, so I know I have to go to quadrant 2. Where's the cosine -√3/2? Is it 120? 135? Or 150? Okay, so you got to remember your unit circle. this actually happens at 150 degrees, or your 5 pi over 6. Now tangent. Where is the tangent? Negative root 3 over 3. Okay, so at what angle does the tangent equal negative root 3 over 3? Okay, inverse tangent, remember, is quadrants 1 and 4. Just in quadrant 4, these are negative. So this angle over here is negative 30. This angle here, negative 45, negative 60, negative 90. Okay? So all of these are the negative angles. So at what angle is the tangent negative root 3 over 3? That's going to be at negative 30 or at negative pi over 6. Okay. Evaluate inverse trigonometric function. Give our answer in both radians and degrees. So the inverse sine is root 2 over 2. Okay. At what angle is the sine root 2 over 2? Oh, I was going to give us the wrong quadrants. We're talking about sine. Sine, again, is quadrants 1 and 4. So keep that in mind. Okay? So quadrants 1 and 4, sine is positive in quadrant 1. And this is always my favorite ratio because that corresponds to our 45-degree angle or our pi over 4 angle. Okay, for part D, inverse sine of 3 over 2. I almost said root 3. This number is bigger than 1. If you look back here, our ratio has to be between negative 1 and 1. So this answer is no solution. Okay? So this number here has to be between negative 1 and 1. Has to be one of our common ratios from our unit circle. Okay, number 2. Finding the exact value of this. And our book has us using the calculator, but we are much better than that. I want us to think of these as non-calculator questions. Okay, cosine of the inverse cosine of 4/7. So remember, what does that mean? This is standing for some angle theta. Okay, draw out a right triangle where this is theta, where the cosine of that angle is equal to 4 over 7. So cosine is adjacent over hypotenuse. I have to find the tangent of this angle. So I have to find the tangent here. So I have to use my Pythagorean theorem to find this third side. Okay. Now I find the tangent of that angle. The tangent of that angle is opposite over adjacent. Okay. And again, our book says that these are calculator. I want you guys to do these without a calculator. Next example, solving that equation. How do I solve for the angle? Well, this is some ratio. Now, I don't know what that ratio is. It's an uncommon ratio, not from our unit circle. So to solve for theta, you have to do the inverse cosine of negative 0.86. And that's just typing in your calculator. So typing in your calculator, you get 149.32. Next example. We have a water ski. I'm already thinking about summer. I'm thinking about water skiing. My brother has a boat. I want to go water skiing. He has a jet ski. He claims it's going to be working. So I'm looking forward. I'm already thinking about the summer. All right, water ski ramp. 5.5 feet tall. 12 feet long. As shown below. Write an inverse trig function that can be used to find theta. So, okay, inverse trig function. I'm given opposite over hypotenuse. That's going to be sine. the inverse sine of 5.5 divided by 12 is going to equal theta, because we're given opposite over hypotenuse. Then find the measure of theta. This is just plugging in your calculator. I get theta to be 27.3. Okay. All right. So that is our inverse trig lesson. There are your lesson questions. Number 1, multiple choice. Number 2, just finding. That's on your calculator. Number 3, and let's round number 2 to the nearest tenth. Number 3, there's a first part. Write an inverse trigonometric function that can be used. So you're going to have a 3a, and then find the measure of theta. There's going to be a 3b. Okay, so I'm going to have 2 separate questions for you guys to fill in there. And please make sure that's submitted on time.